Okay, have you ever imagined to do a toggle LED using lines of code like this, like red, orange, green, and blue LED? Only you will call off toggle LED and it will start toggling. To configure the LED, you just need to write this lines of code and it will get configured. So this is called object-oriented programming. And if you don't know how to do it in embedded, let's learn it. Hi, so let's start to understand how we can use the concept of C++ in embedded. So why we need C++ in embedded? As we know that now the entire IT industry is moving towards object-oriented programming. So with the help of C++, we can adopt we can adopt this object-oriented concept also in embedded C. So what we can do with this object oriented programming in embedded C, there is lot of application on it. Like we have a multiple repetitive work. Like if you say we have buttons, LEDs, then UART, SPI peripheral, everything we can consider is an object with some properties on it. So let's understand why we actually need object oriented programming in embedded. What's the need of it? So let's consider that we have currently three LEDs, red, blue, and green. Each LED is having these all properties that either it can be on, off, or blink. So now in current C language, we need to pass this LED handler like which is the what is the port number, GPIO port number, and the pin number, and then we have to call the HAL function to either make this LED on, off, or toggle. Correct? The same functionality or the same HAL function needs to be called again for the blue LED and same for the green LED. So now with the object oriented programming, we can say that all these functionality can be packed inside a single object. That is, we can call it as an LED object. So this LED object can have all this functionality, and we can create an instance of it object, naming it particularly that color of LED, like green LED, then again one more instance as blue LED and one more instance as red LED. These LEDs will also have the properties like on, off, and toggle. So as you see in the first clip where I showed you that I am just using blue dot toggle LED to toggle the LED, in similar way we will be writing the program so that any instance can utilize all the properties of that particular object. So just remember, we need to have a class. So class is what? Class is a definition of the object, means what all things we are considering to be inside that object. You can say class will contain all the functions that are applicable to the object, like LED on off function, toggle function, and if required some data for that object, like the time till which LED1 was on, like that LED was on, so the off time, on time, delay time, if many a lot of things we can pack inside the class. So class can be considered as a template based on which objects will be created, and this object with different names will create instance of this class. Okay, so let's understand this with the coding, and we will get a good clarity how to create a class, how to create an object out of that class, and how to use the properties. Okay, so let's look into the code. Okay, so I will be using an discovery board to demonstrate this C++ implementation in embedded systems. So let's first create a project. So I am using STM32 Cube IDE. Can directly give the discovery board name, give the project name, and select the target language as C++ to enable the compiler to compile it. Now click finish. So after the project load is complete, then you can see that there are four LEDs like red, blue, orange, and green that are already being defined. So let's now move towards implementation of the CPP file to use this LED as a class object model in our project. So let's create a C++ file where we will declare the class. So I name it as LED control, and the corresponding .h header file also I need to add. So now here we need to include the main.h file. So we include the main.h in order to get the other libraries references here. So we need to create a class. So as I said, the class is a template. So we create a class as an LED. So now the LED will have some properties like on, off, toggle, and these properties will be inside this class. So now we need to declare access modifiers, like who can access which property of LED class. So one will be private and another is public. So we declare public first, and then we have private. So private is not accessible to outside of this class, but public methods are accessible. So first let's declare the constructor of this class. So this is the constructor of this class. And now let's define some of the properties like or operation that we can do, like on, making the LED on, off, making the LED as off, and then toggle to make the LED toggle or blink. And now in private, what we need to consider is we need to store what is the port number of this LED, what is the pin number of this LED. So for that, let's first copy the data types of this pin and port number. Let's go to main file. So here from here we will get the definition of GPIO port and GPIO pin and pin state also. Just copy this, go to the .h file. First we need to create an object of this class using this properties or using this feature, that what is the GPIO type, what is the pin number, and maybe GPIO pin state we can keep it aside for now. And this GPIO X part also we create an instance. So we create a variable that is private to this class that will hold what is the GPIO port number. Let's write properly. And a GPIO pin number. So this will be stored into this class that will hold these properties. So this is the basic structure which is ready. So now let's go and write some functions, declare this function inside this CPP file. So for that, for our easiness, let's copy this for now here. Let's include, and we have this class. So basically how to write, so first is the LED, and then this is the what we call as that, it defines that what is the access point for this function. So LED has these all functionalities. So let's first define the constructor. So we will define a constructor for this class. So this is the reference constructor we will be defining. So how to define a reference constructor, like we have pin state, sorry, we have this GPIO port. So GPIO port we will assign with GPIOX. Then we have pin number that will be assigned with GPIO pin, and we'll close it. So this is the constructor definition done. So now we will be writing the different functions body. So let's write the on function. So for here we will be using the HAL GPIO. So let's include .h file here also. I see now we can have some proposals. So let's go here, copy this. And here what we are having is, first we need to pass the GPIO port, then we need to pass GPIO pin number, okay, and then we need to pass GPIO pin state. So pin state is either on or off will be there. So let's see the GPIO pin state. So the GPIO pin state is set reset. So go here and just give the GPIO pin state. So to making the LED on, we are providing the pin state as set, and similarly we can copy it and paste it here to make the GPIO as off, and this is just a reset. And for toggling the LED, we have GPIO toggle pin port pin number. That's it. So we have written the class. So now we will remove all this, and we have a clean class here where we have, first this is the constructor. We can give some comment as constructor, then we have function to make LED on, and then we have function to make LED off, and then we have function to make LED toggle. So I hope this is clear to you guys now, that in this way we created a LED class. And now let's go to the main function and use this class. So in order to use a C++ main function, we need to modify this C++ main function type. So rename it as CPP, main CPP, because in order to run a C++ file, it should be called from main CPP. Otherwise we need to have some extensions. So let's include led control.h file here. And after these all things, let's first begin and create an instance of led. So led, we create blue, and then we need to pass the port numbers, ld3, ld3 pin. So this is led 3 pins, we have 3 led. So let's just copy paste it. So one is blue, another we say as red, another we say as green, and another we say as orange. So we don't know exactly which LED is for which one. So let's one go and confirm it in main dot. Okay, let's go and confirm it in this IOC file. So we get 3 is orange, 4 is green, 3 orange, 4 green, 5 red, and 6 is blue. So let's write the code in that way. So finally this declaration is done, and now what we can do is we can first write a simple code that we will make this LED as on or off. So let's copy this declaration inside the main file and paste it after we have initialized the GPIOs. So after that we will just make sure that we are able to turn on the LEDs. So let's do one thing, orange dot on. So this will make the orange LED on only. So let's compile the code. Okay, make sure we don't have any errors. Okay, we have some errors. Let's see what's the error here. Okay, we didn't define the return type of this function. That's it. Let's compile it one more time. Okay, now we have zero errors. Let's flash it. So now you see that only one LED is on, that is orange is on. So now it is very easy just to know the color what we want to make on. So let's say we want to make LED blue as on and orange as off after a delay of let's say 500 milliseconds. So now you can see that it is on. Now blue is on after a delay of 500 milliseconds. So now this is, I feel that this way of coding is very important to learn, because nowadays company are asking everybody to learn this way of coding using this C++, so that it is easy to modularize our code. So now you see that just using this four lines of code, we initialized all the properties that an LED should have. And inside the while loop, let's make use of some of these properties, like we say orange dot LED toggle. Okay, and then we get a hal underscore delay of 500, and say blue toggle, then again a delay of 500, and then say red dot toggle, and again a delay of 500, and say green dot toggle, and again a delay. So in this way it is very easy to write the functions. So now you can see it will start toggling in this fashion, where how we describe. Okay, so I hope you understand, and thank you for watching this video. Please subscribe to my channel. Bye.